talking about drones today, deploying drones at scale with Neuron and Hedera Hashgraph. My name is Garrett Coons. I'm with James and Neil today from the Neuron team. Do you guys want to give a quick hello?
James, let me go first. My name is Neil Greenwood. I'm also one of the co-founders of Neuron. I look after the commercial aspects of the business, so I'm very happy to take questions and try to provide answers on what we're doing as business. Looking forward to the discussion very much.
Fantastic. And James already gave a fairly good introduction there, so we can skip right along to him. Some good questions here in the crowd, and if you have any questions, please feel free to put those in the chat. We'll be sure to get as many as we can covered. Appreciate you all for joining us today. And let's dive in. Before we get to the drone aspect, let's talk a little bit about Hedera Hashgraph first. Recording of this call will be available on YouTube afterwards, so feel free to drop if you need to. You'll be sure to make sure you don't miss anything. So to really start with Hedera Hashgraph, for those unfamiliar, we're really focused on this enterprise adoption of public distributed ledgers. There's a few things that we believe have to be corrected, improved upon in order to reach that mainstream adoption, if you will. Performance, security, stability, and governance, I think are all at the top of everyone's minds these days when it comes to this technology and the innovation that it can create. Hedera does a good job of solving that. And we really believe that we're this next generation of public distributed ledgers architected from the ground up for these new types of highly scalable, highly efficient applications like the ones Neuron is building. So we're so excited to have them on the call today and hear a little bit more from them directly about how they're using Hedera to innovate really within this drone space. And like I said before, we are a little bit faster compared to other technologies out there. Have a little bit lower fees that are predictable in finality in seconds. So all of this comes together to have really modern applications being built on us that I think you're going to be excited to learn more about. And today we're talking about Hedera Consensus Service primarily. So if you haven't really checked out Hedera, we do have two primary Hedera network services. These are APIs that developers can tap into and quickly build applications with. Consensus service is really for sending, any arbitrary event data to the ledger and doing so very quickly. Token service is for minting, defining those tokens, NFTs, a ton of stuff there. All of this, of course, uses our Hashgraph consensus algorithm under the covers to provide that fast, fair, highly secure consensus. And this is all governed by the Hedera Governing Council, which is a set of up to 39 term-limited organizations that span a broad array of industries and locations to provide fair, decentralized governance really across the ecosystem. And so with that, that's a quick primer on Hedera Hashgraph. If you have any questions, feel free to reach out to us. We're more than happy to chat. I'll hand it over to our friends at Neuron.
Brilliant. Let me just try and share my screen.
Yeah, go for it.
There we go. Okay, great. So hopefully you can see this okay.
Yep.
Wait for this to actually load up. There we go.
Perfect.
So, yeah, I'll sort of introduce us and then I'll hand over to Neil at some point. So what we're going to talk about today is how we believe that drones are going to scale globally. And we're using Hedera Hashgraph as one of our parent technologies. And talk about a little bit about why it's so important within the drone industry, what it is that we're using it for, and why Hedera, I guess. So myself, I'm James Dunthorne. My background is in collision avoidance research for drones. So I've been in the drone industry for about 11 years, aeronautical engineer by background. I've then done a lot of consultancy worked with PwC and their drones team, and also as a regulatory consultant within the aviation sector. I'll let Neil introduce himself.
Yeah, hi, thanks, James. Neil Greenwood. My background started in the military aerospace area, working with surface-to-air missiles for a long time, but particularly on the integration of drones into the aerospace in the early 2000s. I've been in a number of different roles in technology startups and investments since then, and also I was a managing director of NATS, which is the FAA equivalent.
Brilliant. Thanks. So we all know the vision of what we see of this Futurama style world ahead of us. And this picture's been painted for a number of years now. We've got things like drone deliveries for medical supplies, long linear infrastructure inspections for drone technology, air taxi flights, so passenger carrying vehicles, electric VTOL vehicles. This is just in the aerial sense, but things are going on the ground as well, with ground robots delivering your shopping, and autonomous cars replacing taxi drivers. So we can see that the world of mobility is going to be changing. No one knows quite when, but certainly a lot of the foundations have been built now. But there's still a problem, because the reality is that we still look at our roads and they're clogged up. We've still got FedEx lorries sitting there delivering parcels. We're still using motorbikes for delivering a lot of our goods when we're talking about speed. And drones are not nearly being used as much as they could be. We've got 2050 targets for climate change. This is a big driver behind a lot of the new electric VTOL, vertical takeoff and landing aircraft out there. And drones play a huge role in this new reality. So how are we going to move across to this? And what's stopping that? What's the big problem? Why are we not seeing these in our skies? Well, you wouldn't believe, but drones and aircraft still cannot see each other. With all of this technology that's out there, the internet, AI technology, VR technology, blockchain, DLT, the whole works, they still can't see each other. And this should not be a hard problem in 2021. We saw the effects of this at Gatwick in December 2018, just before Christmas, where everyone seemed to hate drones. They stopped a lot of flights coming into Gatwick Airport, and from going out, and people wanting to go out on the holidays to see their families over Christmas. And this was all caused because someone said that they saw a drone, and yet the authorities couldn't find it. They were looking for it. They had all of these reports coming in. And it actually turned out that a lot of that was down to the police deploying their own drone to try and look for this rogue drone that we still don't know whether it existed or not. But the key was here that there was a clear, there was data. We have access to huge amounts of data out there, but people weren't getting access to that data at the right times. How are we monitoring where the drones are? How are we monitoring where the aircraft are? And how do we combine this together into a single picture so that they can see each other? This is really, really important when we consider safety of integrating these drones into civilian airspace. And the result of that is that the regulators won't allow them to fly further than the person can see. So you always, when you're flying a drone at the moment, you always have to have a pilot within view of the drone when you're flying. There's probably one or two people out there who flex the rules a little bit, but on a commercial basis, these are strict rules you have to follow. So how do we actually be able to, and how do we see or take these things beyond visual line of sight? Well, the way we do that is by being able to see what's around us and giving the drone a digital vision of everything that's in the sky around it. Now, what's that opportunity worth? So we've looked at multiple sources, IATA, Markets and Markets, and the European Air Traffic Management Master Plan. These are three very reputable sources, and we sort of took an average of these points, and it translates to about 2.7 billion drone flights per annum is what we're looking at on a global scale. And we think that we can, with our solution, we're targeting around about 1.5 billion of those flights per annum. And we think we can capture around about 360 million flights of that. So we're talking about a very sizable market here. These flights don't have to be worth very much in the way of pounds and dollars for them, for that to be worth a fairly significant market. So it's a problem that's definitely worth solving. So how do we currently solve these kinds of problems? Well, there are lots of these solutions out there. We've got things such as radar systems, we've got things such as transponders, but there is no silver bullet out there at the moment. But lots of complementary solutions, which when combined together, provide you with a complete airspace picture. So radar, for instance, is tens of millions of dollars to go and deploy one of these systems. They're huge machines, take up a lot of space, huge power requirement, so not so friendly to the green people out there. And they basically just jettison huge high power waves up into the sky and wait for it to deflect off things. Now, the problem is drones, probably a lot of them are about the same size as birds. So, and radar systems struggle to see birds, and they also struggle to see drones. There are some out there, some newer ones which can see drones, very small drones, but even then they are even more expensive than the standard radar systems. You then have something called a transponder. So transponders are basically what we call an active sensor. So they actually, you have these sensors installed on the aircraft, and they basically like a beacon. They're flashing their position to anything that's around it and might be listening in. Now these transponders, there's lots of different types of transponders out there. So you have something called ADSB, which some of you in the audience might have heard of. It's just a protocol, basically. It's a data standard. You then have something called FLARM, which is what glider pilots use. They're very common amongst gliders and in general aviation, so small Cessna planes. You have things such as pilot aware, which is more of a bespoke a transponder system. Mode S, Mode C, Mode A, I could go on. There's loads of these different systems, but unfortunately, a lot of them don't interoperate with each other. So for instance, an ADSB transponder cannot be picked up by a FLARM transceiver. So how do we actually, it seems crazy really, we live in this world where, from a safety perspective, you can't see everything that's around you. So how do we build up that picture? So first of all, I'd like to sort of talk about why we've decentralized our solution, how we created a shared airspace picture, how we've enabled high data throughput, how do you incentivize data sharing, and how do we ensure provenance, accountability, and audit with the data that's going through our network. So let's go on to our solution. Well, sorry, why are we decentralized first? So, we could have applied a standard database to this problem. Now, the problem with applying a database to this problem and centralizing this problem of this kind of single airspace picture is that imagine if Google went and deployed all of these sensors across the country, and then they were flying their drones using these sensors on the ground. And then Amazon came in and started wanting to fly their fly their drones. But Google weren't very keen on letting them use their sensors on the ground. So Amazon then have to deploy their sensors. So what you end up with is this, what we call the data censorship problem. And I'm sure a lot of you distributed ledger technology fans will be very familiar with this one, is that basically data infrastructure and service provision are chained to each other. They're chained in such a way that if you own the data and the infrastructure behind that, then you can monopolize the service. And you see this in a lot of industries. Once you've got the data, then you can control the market. What we're trying to do here is to break these two apart and unleash these chains and actually separate data ownership and service provision from each other. So our solution in doing that is by creating what we call the shared airspace picture. So we integrate thousands of data sources, and that's from ground-based sensors, from radar systems in airports, and also from the drone systems themselves. So we can hook into their ground control stations and computers and pull data from them to track their position across the sky. So we integrate all of those into a distributed network. And we talked about why we had that distributed network. We want to overcome some of the censorship problems. There are also some other reasons in there around failure. So if our system were to fail, we need kind of some redundancy in there. And we also need correct political governance within that network, which I'll come on to a little bit later. But all of that data is then concatenated in that distributed network and then integrates into leading pilot apps so that collisions can be avoided. And so essentially those pilot apps are the things that drone pilot will fly their drone from. And we connect our API into their ground control stations, and then they can see all of the aircraft that are around them as they're flying. Now, over time, those kind of systems will automate. So we'll see, algorithms being developed, and we're already working with a number of partners who are already working on those algorithms to avoid collisions automatically without the need for a pilot to be in the loop. But the first stage is to at least get this data in front of the pilot so they can make decisions. We then it's very, very similar to like the autonomous car, where we have a safety driver behind the steering wheel. And once we've got the safety driver behind the steering wheel, we can then start increasing automation. And we see a very, very similar pipeline of development going on in the drone industry as well. Now, how do we get the high data throughput? We talked about this distributed network here in the middle. So how do we get the high data throughput? Well, we're having to rely on probably suboptimal leader-based consensus algorithms for our network, and some other sort of more traditional algorithms. And I'll get onto a little bit later about how we get the best of both worlds. But we've got a cross-cloud node software, which we offer on free license to third parties. And it's all driven by APIs and microservices, and scalable distributed network architecture. All of this is being developed to aviation grade software assurance standards. So when we start putting this out there into and getting regulators to approve what we're doing, then they want to see these kind of assurances in place before they'll approve anything. So this is really important for us. But yeah, we're using leader-based consensus algorithms mainly at this with our own, we'll call it our AppNet, as some of you might be aware of. And this AppNet, the reason why we do this is purely for speed and throughput. And so what we have there is this network is cross-cloud, near real time. So we've got current latency of less than sort of 100 milliseconds. With thousands and thousands of transactions per second, we're able to push through this. But it has some geographical constraints. So we have to have nodes very close to each other. We can't start beaming things across the world. We need to start thinking on a more geographical level. We then have our Synapse Link. Our Synapse Link is what we use to go and get data into our network. So this basically is just a network switch which allows people to connect their sensors and then and push them into Neuron. You can integrate directly with Neuron's APIs, but if you've got a third-party sensor which isn't already integrated, then this Synapse Link allows you to connect it into our network without relying on third-party integrations. And we use tokens to be able to authenticate that data. So every single thing that's connected to us is fully authenticated with tokens. And we actually take the companies that are connecting those sensors through a KYC process to ensure that the data is coming from a reputable source, and we know whose door to knock on if it isn't. But then how do we get all of these sensors out there? So the incentivization piece is really important. So what we do at Neuron is we just facilitate the data sales between the data provider and the data consumer. So the data providers are the sensors, or the radar operators, or the drone operators who are sharing their data with other people. So these are the sensors. And actually, when we start thinking about other applications, which we might come on to after the presentation, a sensor can be pretty much anything. It could be a mobile phone. So the potential for this kind of architecture is potentially massive here, and that data then passes across to the vehicles or the data consumers, and they basically then pay for that data on per minute or per hour basis, depending on the data type. But we just take a commission on those data sales, and we also take a commission on the app services. So, for example, the app we have with this surveillance as a service is the Fusion algorithm, which basically takes all of those data sources and fuses it together into a common airspace picture. So we take a commission on data sales, we take a commission on the app service. So other third parties can integrate their own applications with this network. And that works out to be around about £1.29 or about $1.70. Was doing some quick maths per flight. So when we're talking about 2.7 billion flights per annum within 5 years, you can see that there's a lot of potential in it. So where do we use HCS? Why do we use HCS? Well, we use HCS when we execute each transaction. So we have these transactions going through our network, so data coming in, and then transactions going out to provide the drone operators with the airspace picture. And these happen every second. So we're looking at a throughput of around about every second. So every time we execute these transactions, what we want to be able to do is to create a record of what actually happened in that time. There's a few reasons for this, but basically it's an audit. It creates an audit trail for us. It's really important when it comes down to liability. So when you've got a drone flying along and say it crashes into an aircraft, then who's responsible for that? And what we don't want to be in a position is that people aren't accountable for their actions. So it's really important, especially when we start looking at autonomy and drones flying autonomously. We don't want to get into this world of Skynet where you've got killer robots hurting each other, and then everyone pointing their finger at someone else. What we want is that we want a system where companies are accountable for their actions. We can record and audit exactly what happened in the sky at any given point in time. And we want to be able to know where that data came from. So we want to be able to understand the provenance of that data as well. These are all really important things for us. And we don't get that by using our leader-based consensus algorithms within our network. We don't get this. Whereas with Hedera, we do. So this is where we're using Hedera to execute when we execute each of those transactions. And those transactions by using Hedera can be independently verified by third parties. So we can show a regulator, for example, or an air accident investigator, all of the data that was provided to the drone operator at that time, and then that can be independently verified on the Hedera network by those third parties. So that's really a really nice sort of piece that we can do here. And why do we use HCS? Well, in terms of its throughput, we're looking at, tens of thousands of transactions per second, which is what we need. We need a lot of TPS. We also need low cost. When we sort of started talking about that kind of throughput, Bitcoin, which I think I've seen some transactions where it's costing like almost £100 per transaction. Well, we'd be out of business very, very soon or very quickly if we had transactions fees of that sort of order of magnitude. But when we're talking at thousandth of a dollar, then that's the kind of price that we can afford. In terms of predictability, obviously, from a business perspective, we want to be able to have some predictability about the service that we're using. And given the low latency of the network, this also leaves a very, very small gap that someone could alter the audit trail, basically. So the smaller that latency, the better for us, because we can then, it's very, once that 4 to 5 seconds is gone, then that what happened is immutably recorded. So we're operating our own governance council. So we are working with a number of household aviation names. So you'll probably know some of them. People such as, for an example, Syrian, Collins Aerospace, who are part of Raytheon. We've got some partners such as Heathrow Airport, some of the big airports. So these are the kind of people that we need to go and have accountable for this private network. And then we use a consensus service using with Hedera to then have the next layer of governance, which goes across the audit trail for us. So it's very important that we have this kind of two layers of governance. One, to talk about things such as data standards, which are quite important. We need to understand what formats we need to share this data in with each other. We also need to talk about things such as what the rules are for or what the performance requirements might be for your hardware that you're running, and these are all matters that we can decide amongst within our private network. So we've got some projects that are ongoing. So we're establishing some drone zones across the UK. And these drone zones are basically areas of airspace where everything has to be transponding using it has to be attached with a sensor that will transpond its position. So we're building some relationships with mobile network operators, some very household names to do that, to deploy sensors across these regions. We're creating these networks and drone operators and connecting in drone operators to then start flying within these areas. So we'll feed them with that surveillance picture from the sensors and provide that straight into the drone pilots' control stations so they can see what's around them. But people like Vertical are one of the big air taxi companies. So I think they recently received, I can't remember the amount it was, but huge sums of investment. So they're alongside Joby, who are another huge air taxi operator. We've then got people like Windrace and Skyports and Hiroteke and Raytheon, who are also partners we're working with in the UK to fly drones within these drone zones. And we're working with local authorities and governments to deploy these because they're very keen to see these technologies and attract these technologies to their areas. And this is a video of actually one of the trials we were doing with a company called Hiroteke. So I've muted the audio because I didn't know how well it would come through. But basically, we were doing deliveries of small medical supplies to ships out at sea. So the drone station is basically it's a box which houses the drone. It recharges the drone automatically, and then these flights were performed fully automatically. So no human intervention. Obviously, a human monitoring the system while it's working. But you can see the boat rocking around, and we actually did 8 landings and managed to get all 8 out of 8 landings on the boat. But we deployed the sensors and we fed that sensor into the drone pilot so they were able to monitor airspace. And so what you would have is a situation here where you could have a drone on demand, basically. So you have one of these boxes at a given location, and when someone needs to deliver an item off to a boat, then they simply attach the item, and a pilot could be operating or monitoring the device from anywhere in the world, essentially, using this service. And they don't have to stay within line of sight because they're using our sensors to be able to see what's around them. That's really important. And that's the end of the presentation, but I dare say there's probably hundreds of questions, or hopefully there's hundreds of questions in the chat box, and hopefully you enjoyed that. These slides are available on neuron.world/Hedera, or they will be shortly after the event, and that you can also subscribe for updates from us. So we'll be doing regular monthly updates on our progress and let you know what we're up to. So you can, if you go on neuron.world/Hedera, you can pop your email address in there, and we'll update you with all of our news and updates. So yeah, thank you for listening, and yeah, let's start doing some Q&A.
That's fantastic, James. Thank you so much. And do have some good questions from the crowd. Let's just start with the more aviation focused ones to begin. What does integration look like for your end users? And do you manage all of the cryptocurrency kind of blockchain aspects entirely for them?
So in terms of the, I'm just trying to understand the question a little bit more. So how does it, can you repeat that again?
What does integration look like for your end users or your customers, I assume? How does a drone start to use Neuron?
Got you. Okay, so they start using it through their ground control, through their drone manufacturers' products. So we actually integrate our APIs into their drone products. So for example, Hero Tech 8, you saw there, the drone in the box provider. They've integrated our APIs into their software. And what that means is when the pilot's flying around, they can see it on their map. So in terms of the actual integration for the customers or the end users of this data, they just work through their native applications. So our task at the moment is working with all of the different manufacturers to integrate this service with them, and get that into their products. And what we don't want to do is them having to use a completely new product, having additional products and having additional screens in front of them. We can actually put that straight into their existing screen.
That makes a lot of sense. And I assume, are these typically, JavaScript, Python apps? Like what are we looking at here typically?
Yeah, so the actual applications could be all sorts of things. So they could be, Windows-based applications. They could be apps. So DJI Go app is, you can download that in the App Store, and you can download that on iTunes, the iTunes Store. So it could be across anything really, and you don't necessarily need to use. You could also access it via the web. So we actually have a preview on the back end of our software, which allows you to actually see the view,
Cool.
in that native application.
Very cool. And then a common question we got throughout is really like, do you see this Neuron technology being applicable across industries? And if so, which ones jump out at you?
Massively, yeah. Well, the problem we're solving here is like a real-time data problem, where you've got like an auditable record of all of those transactions. So this plays into safety-related industries quite well. So, for example, aviation is a great one. Autonomous vehicles, I think, would be another fantastic one. But when we start looking sort of a little bit more widely, we can start sort of seeing actually, well, there's quite a lot of people who want to sell data. One of the problems that you have is that when you try and push data through sort of a distributed ledger, is that there's a transaction fee, which kind of is actually disincentivizing you to share it. So how do you actually go and get sort of like a trusted data platform where you can share your information and know that you're going to get paid fairly for all of your information, and it's your privacy is being respected and all the rest of it? Well, you need a distributed architecture, but can you actually, what you can do is you can actually find a buyer before you actually sell the data. So once you've found the buyer, then you can process the transaction, and the transaction fee is only paid at that point of sale, rather than trying to push data through a distributed ledger in the first place. If you do that, then it just costs money without actually necessarily having a customer on the other side. So if you actually take that onto a second layer solution, then what you do is you actually get the benefits of the distributed DLT without actually having to, and you're able to incentivize people to share that data in the first place. So that's really important.
Yeah,
So,
absolutely. That makes a lot of sense in terms of bringing the data online first, and then creating really a marketplace around the information. Where do you see reputation fitting into that system?
Yeah, that's a really good question. And, we've been humming and hawing about a token for a good number of months, even up to for the last year, I would say. But at the moment, we're not going down that route yet, but we've got some ideas around how the reputation could be tokenized. Because one thing that we could have a problem with our network is, how do we actually stop people spamming the network with rubbish data? And one way to be able to do that is to actually have some kind of reputation from a user. So if a user wants to share their sensor data with us, then they can almost stake their reputation to be able to share that data. And if it turns out that they start spamming the network, and someone flags up that they're spamming the network, then they lose their reputation. And reputation is quite valuable, as we all know. So there's some really interesting ideas that we've got around this. We're not doing it yet, but watch this space, and we'll see where that goes.
That's super exciting. In terms of the actual drones themselves, you may be able to answer this more than I can. Do the drones typically have detect and avoid technology built on board, or is that part of the transponder configuration?
Yeah, so you can get like onboard what they call them like detect and avoid systems. So a detect and avoid system is would generally be, has always traditionally thought to be on board. So the problem is with onboard systems is, they might be using things such as video cameras, or they might be using things such as radar systems. Well, video cameras are terrible because pixels aren't very small. They're actually quite big in comparatively. So by the time the video processing algorithm sees the aircraft, it's not really got a lot of a chance to then actually escape. The closing velocity of drones and aircraft are huge. You've then got things such as radar systems, which you can put on board the drones, and they will see everything that's around them. But the problem is with those radar systems are incredibly heavy and power hungry, which isn't really conducive for a drone system. The next option, and the only real option, is to go down the transponder route. But as I sort of discussed earlier, there's so many different types of transponders out there that actually there's no real one size fits all. And a lot of those systems need to be, so things like Mode S, for example, you can only actually detect Mode S by having a minimum of 4 sensors within range of it. And because they triangulate the position of the aircraft using multiple sensors. So if you're wanting to detect all aircraft, you need to have some kind of ground-based infrastructure to be able to do that, regardless of whether you've got anything on board. Yes, it's probably a good thing to carry something on board, but it's not going to be a complete solution for you. But we can actually take the data from onboard sensors as well, and feed that through the telemetry link of the drone, and pull that into the network and sell that as well. So we actually see that as a almost like a moving sensor for us, which has usually got quite a good vantage point. So drones don't necessarily just have to be buyers; they can also be sellers of data. It's really just a case of trying to pull all this data in, to create a vacuum where people want to push this data.
That's super interesting. And then we have, a couple more, I think, industry-specific questions for you that you may or may not be able to answer. What is the process like to get approval for regulations in the aviation industry? I imagine there needs to be extensive testing done to prove the safety and reliability.
Yeah, exactly. So there is, we're under, in the UK and across Europe, we're under a regulation called EASA, which is European Safety. I never remember what it is, but European Agency of Safety for Aviation or something like this. But they basically regulate things, and you've got 3 different categories of operations: so open category, specific, and certified. Generally, most drone operations at the moment sit in the specific category. The open category basically means you don't have to apply for permission, but it's quite restrictive in terms of what you can do. The specific category basically says, okay, you can tell us what you want to do and we'll tell you if it's safe or not. The certified category is for like the very high risk operations. And some of these kind of things will go in that higher category, but I would say, given that there's not a lot in there at the moment, or I don't think there's any certified aircraft, or if they are, you can probably count them on one hand. So I think everything is going to really sit in the upper end of the specific category. And what that means is you have to submit paperwork, which basically provides I would say, a qualitative assessment rather than a quantitative assessment. So it's very much a case of providing a risk assessment, showing your mitigations that you've got in place, and providing evidence that you meet certain levels of safety. And so when it comes to our system and the software assurance that sits beside that, that's used as a means to demonstrate the the reliability of the system. So this is really important for us. Otherwise, if people are relying on this to avoid collisions, then it's very hard to make that argument to the regulators. So and this is actually what I did in my previous job, is I used to make these arguments to the regulator and write all of this documentation. So it puts me in quite a nice position because I understand the process. I understand sort of a lot of the requirements of the regulator. So when it comes to developing our software, we can make sure that we tick all those boxes.
That's fantastic. And I think there was estimations you mentioned of, 2.6 billion drones being online in the world. So there's certainly, I believe, a aggressive need by regulators to close this gap. Are they feeling that in your conversations? What's the situation like?
Yeah, so that 2.7 billion is a 5 to 6 year forecast. When you actually look beyond that, sort of around the 10-year mark, the figure is actually quite substantially more than that. So, we could see quite a significant growth over the next sort of 20 years of this kind of stuff in the sky. And it doesn't actually, 2.7 billion flights per annum. I think it works out to be somewhere around about. I think it was about 200 flights in London per hour or something like this on average. So it's actually not, on the grand scheme of things, it's actually not a huge number really. There's already a significant number of flights or drone flights in London already. But they're all sort of visual line of sight, just roof inspections and things like this. I forgot your other question. Sorry, can you repeat that?
It's just the importance of regulators and their understanding of this coming down the road in your conversations with them and needing to find a solution like Neuron in a timely manner.
Yeah, exactly. So regulators are putting a lot of work into this. So it was actually funny. I think it was on Monday, the CAA, this UK CAA, Civil Aviation Authority, they put out a call for anyone with detect and avoid solutions. So they've got an innovation team who are actively looking for solutions in this area. We've actually had an application in for a while with working with them, and we're already working with the CAA's innovation team. So, they've been supporting us in some of our work we've been doing with our MediDrone project, which was that video you saw at the end of the presentation. They're very supportive of this kind of thing. They know that this is one of the big sticking points that's stopping drones from progressing forward. So super important that we get this solved, but we need to make sure that we're not we don't want to be slowed down by regulators. The regulators' primary function is to slow you down. That's what their job is really. So as a technology provider, we want to try and push them quicker, but we do have to tick all the boxes and satisfy them that what we're doing is safe. Safe enough, I would say. You can always be safer at anything. If you stop crossing the road, you're never going to get hit by a car, but maybe the shop's on the other side of the road.
Of course, especially with this critical of infrastructure, I think that makes a lot of sense. Okay, guys, we are just about out of time. Any closing thoughts that you want to give away, Neil or James?
Thanks, Greg. Yeah, I'll just add one point really, which is in summation, I guess. We're on the dawn of a new age in aviation, and it will see an explosion in drones and ultimately air taxis. We are already forecasting 10x increase in platforms in the future. And as James says, that will become many more in the future. Hedera Hashgraph really helps us solve the problem of the safe separation of aircraft. It's very near real time, so the speed's great, high transmission rates. It's a very secure and resilient solution. But more than anything, we love the governance approach. We think that's going to turn the whole industry on its head. It's going to allow the participants to state the standards for the market, think about data standards, API standards, this type of thing. And that's really going to allow this market to reach its full potential. So we're very happy to speak to partners, to speak to investors. There've been a couple of questions about how we're progressing. The answer simply is as fast as we can. There's huge appetite for what we're doing in the market. And we're delighted to be working with Hedera Hashgraph on such an exciting project.
Fantastic. We're certainly excited to be working with you as well, in such an impactful way and very exciting space. For those that want to get in touch with you, I do see the email here, contact@neuron.world. Other good ways to follow or stay in touch with Neuron?
Yeah, so we have a Twitter, which is Neuron_world. I should have put it on here, really. I've never been really that big on Twitter, but we have recently, because we started getting loads of attention for some reason. But yeah, Neuron_world on Twitter. You can go to our website, which is neuron.world, and if you go to /Hedera, then you'll stay in contact with all of our updates. But yeah, if anyone has any further questions or would like to reach out to us, then feel free to just hit our email and just try not to fill it up.
Very good. Well, thank you guys so much for this presentation today. I think it was very insightful and we learned a lot about this new industry that's quite emerging rapidly. So thank you so much. We're excited to see how Neuron progresses.
Thanks very much, Eric.
Thanks for joining us all. Take care.
Thanks, everyone.